Hey everyone, today we will see problem number 378 from the LeetCode, that is kth smallest element in a sorted matrix. So what's the problem? This one is a medium level problem, and we have been given an n cross n matrix where each row and column are sorted in ascending order. So we have been given an sorted matrix. This is the first case. We have to retain the kth smallest element from the matrix, and we don't need to consider the distinct element. Okay. uh, and one more thing, they have been given that you must find a solution with a memory complexity better than order of n square. So we have to keep memory in mind also. With time we have to keep memory too. So they have given some examples. First is they have given a matrix of 3 cross 3 order, and k value is 8. We have to find the eighth smallest element from this matrix. So it's 13. Let's take it. So we have three approaches. First is brute force. That is, we have to traverse from all the elements and find the eighth smallest element. But this will take a lot of time. So time complexity will be very high for that approach, brute force approach. So we will not consider that. The second is we have a data structure called max heap. We can consider this because a time complexity is n log k for this, but space complexity is high. We need extra space for this case, max heap. Okay, so this is a shortcoming, but let's check this approach too fast. In this approach, we will use a data structure called max heap, in which elements are stored in sorted order, and uh, like we add elements in this structure 1, 5, 9, 10. We are adding one by one. Okay, 13. Now 13 come after 13. We have seen that 12 come. 12 came. Okay, 12 came. But we have already 13. So what it will do, it will remove that 13 from here and move it to the next index. Okay, so it becomes sorted. Now next is 15. Now what we need is, we need the kth smallest element, like we need eighth element. So if we can make the condition like if the size of the heap. Okay, we will create it through priority queue. So if the size of the queue is greater than, if size is greater than 8, then we will pop the topmost element. So by this we will have only the smallest element. Uh, let's check the code for this approach. So first we have written the code in C++. First we generate a priority queue, that this is only the max heap in C++. Okay, this is a data structure already generated for us for max heap. Now we are iterating for the matrix for its size I0, I less than matrix size I++. Okay, then we are iterating and we are pushing the value in the queue. And if likewise I said that if the size is greater than k, we have to find the kth smallest element. If the size is greater than k, then we will pop from the queue. Okay, and what pop will do, pop function will take out the largest value from the priority queue, from a heap. Okay, and at the end, after traversing complete array, we will retain the topmost value, and that will be our answer. Okay, now check out the second approach, that is more time efficient binary search approach. So what in binary search, what we have to do, we will first find a low value and high value, and then we will find the midpoint from that, then we will discard one side and use the other side according to the condition. This is what we do in binary search. Okay, we will divide our data to which we have to do operation. As a given matrix is sorted, so we can use, because this is the sorted matrix, we can use binary search approach here. Okay, now what we can do is how we can find the low and high value. Low is the first value from the matrix and highest is the, because the matrix is sorted, the all the row wise it is sorted. Okay, the zeroth index, the value is the lowest in the row, and likewise column wise it is also sorted. Zero at zeroth index, the value is the lowest. Okay, so 1 is the lowest value in this matrix and 15 will be the highest, so low will become 1 and high will become 50. So then we will find the mid value. First point is that notice that we are getting the low and high value as the actual value, not the index. Okay, now how we will find the mid value? As 1 plus 15 by 2, that is 16 by 2, and which will be equals to 8. So our mid value will be 8. So first we will check that our k, our value k is greater than 8. Okay, then let's go sequentially. Then what we will do, we will we will find a count of values which are less than the mid value. Okay, first we will find the mid value, then we will find the count of values which are less than mid value. So how many values are less than 8 here? 1 and 5, there are only two values, but our k, a, k is 8 and the count is still 2, so we only found out two values from the 8. Okay, so we need more smaller values. So what we will do, we will update the mid and high value, and we will check again from the matrix. So now what we will do, we will make the low equals to mid plus 1 and high equals to high will remain same. Okay, high will remain same. High will remain same. Now what we will find, we will find the mid value. Now low will become 9 and high is only 15. Okay, so 9 plus 15 by 2, that will be 4, 10, 10, 24. 24 by 2, that is 12. Okay, so next our midpoint will come to be 12. Now we have to check the values less than 12. How many values are less than 12 here? So how many values? 1, 2, 3, 4, 5. Okay, so 5 values are less than 10, less than 12. Sorry. Okay, now what we will do? Still our count is less than k, so we will update the values. Now what we will do? We will do low equals to mid plus 1. So what will become? Low will become 13 and high is still 15, and we will find the midpoint from adding to 13 plus 15 by 2. 28 by 2, and it will become 14. Okay, so our next midpoint is 14. Here, 14. So let's see here. Its next midpoint is a 14. This was 13. Okay. Now we have to find values less than 14. How many values in the matrix are less than 14? Let's check that. 1, 2, 3, 4, 5, 6, 7, 8. Okay. 8 values are less than 14. So we have found out. So we will return the last value, 30. So let's check the code for this binary search approach. First, what we have done, we have find the value for the size of matrix. Okay, then we have defined the low value, that the first value in the matrix, and the high value as the last value in the matrix. Now, while low is less than high, we have we are defining mid value as low plus high minus low by 2, as in binary search we do usually. So then we define a count value 0, initial count. Then using the uh, upper bound method in the uh, C++, we are getting that what upper bound will retain. Upper bound will retain the element, the index, the next index at which the element, the value is more than a desired element. Like this, we have an array 10, 20, 30, 40, 50, and we are finding the upper bound for 30. So what will be the upper bound of 30? It will be 40. Okay, 0, 1, 2, 3, and 4. 40 will be at index 4. So upper bound will be 4. So what upper bound will return? Upper bound will return a index value, address at which the value is greater than our desired value. Okay, then what we first we are creating the upper bound, then we are subtracting it from the first value at that index. Okay, matrix I dot begin, first value from the, like if upper bound comes 9. Okay, then we are subtracting it from 0 minus 9, 0 minus 2. So if count is less than k, after iterating for all the values in the matrix, if count is less than k, then we will update low as mid plus 1, else high will equals to mid. Okay, if count is greater than k, uh, if count came to be greater than k, that we have more number of smaller values than that mid value, then we will update the uh, high value as mid. Okay, our search will come leftward, and then at the end we will retain the low value as a result. So by this, your all the test cases will get passed. Thank you.